Hello everyone. Now we are going to discuss about design space exploration and its automation script using Python. So firstly, what I did was I've attached all the file paths in this code. As you can see, the sublc code, the attribute file, the info file, and the output file to be generated. First, what I did was I created a dictionary to store all the attributes. Once it is done, I have opened the libinfo file, which is in this format. So what I did here was I have disregarded all the lines with the hash, like this indicate their comments. So that is what I've done here. If line starts with hash, just split that line and format accordingly with the attribute name and attribute value. So basically key pair values, key value pairs. So then next clear the list of all the combinations. That is step 2. Now go ahead and create the header for the CSV file. I have taken the 3 columns of combination, area, and latency index. Once it is done, we have to go ahead and generate the QR for every combination. Since we don't have, like, it cannot access the tools directly, I have given a random values for the simulation purpose, and it returns those values to the file. Once it is done, we have to loop through each attribute combination, generate the QR, and show the results. To do that, we need to have a header file with the for every specific combination. The header file is like this, which contains the main attributes included in the code. So after that, we have to append all that result to the list we generated back in here, which is attribute combinations. Once it is done, once everything is done and the combinations has been run, we have to store the results in a CSV file. To do that, first we have to create a new file output CSV with the path given and give it a write permission. And create an iterator called row in the results, so whenever there is a successful write to the CSV file, it generates a statement called successfully wrote to that file name.csv. If there's an exception, it throws this exception. So this is the whole code. So once we go ahead and run this code here, so as you can see, it successfully wrote the file outputs to CSV. As you can see, the files have been generated. So I've already went ahead and done this. So as you can see, this is the output I've got. So as you can see, for the different combinations, I've exported a different area and latency index. So since we have so once you open the header file, once you open the lib.info file, which is here. So as you can see, depending on the count of the attributes here, we can estimate the number of combinations we can generate. So as you can see here, 3 into 4 into 4 into 2 into 2. So this comes out to be total of 192 combinations, which is what you can see here, 193. So the 93 is because of the one line for the headings. So as you can see, these are the combinations which have the latency. So I have sorted the combinations according to latency index. Now we'll go ahead and plot the scatter plot. So select the area and latency index, go to insert, go to charts and insert scatter plot. Index. So as you can see, for different areas, there are different latency indexes obtained. So this is a scatter plot for that. So this is what we have done in this project, part of the project. So we have extracted the different combinations of the attributes included in the header or info file, and compared different areas of the combinations with different latency indexes to figure out. So as you can see, we desire the latency index less and the less area, which is this one. So that is one. So this dot indicates not only the one combination, this is the like group of combinations which is indicated in a single dot. So that is how design space exploration for this homework. Thank you.